Today we're going to go through the three problems that we went through in class prior. These are called the density problems. So this is your equation, which is density equals mass over volume. You have specific units, so mass has to be in grams. V is volume, which has to be in milliliters or cubic centimeters. So that would also mean that 1 milliliter equals 1 cubic centimeter, which would be length times width times height. And so density would have to equal grams per milliliter or grams per cubic centimeter. So those are the formulas we have to deal with. One little thing we need to remember is that the density of water is equal to 1 gram per milliliter, and we'll stick with that because it is a fluid. Okay, we're going to go through 3 of the problems that we went through in class. This is again the second, number 2. Now if you're doing calculations, most of the time you're just interested in what you're trying to find, and the 2 or 3 or 4 or more variables. And these are my variables. 2.75 kilograms, 250.0 cubic centimeters, and we are trying to find density. We know we are aiming for an end result that is going to be grams per cubic centimeter. So if we start going through and filling in our factors, first of all, we know that the cubic centimeters are actually now in the correct unit. And the grams does not agree with the kilograms. So we got to convert kilograms to grams. Nice easy way to do it is King Henry died by drinking chocolate milk and converting from this to this. Now we know kilometers is the big one, base is the small one, and if it's the big one, it gets the 1, and we know our other factor is going to be 1,000 grams. We'll do a quick conversion for that, 2.75 kilograms. The big one again is kg, so we put the big one here, and then we have grams up here, and this number goes with grams. Then all you have to do is just multiply these two numbers together. Since there's a 1 at the bottom, we don't worry. So it's 2,750 grams. We have made sure that we're in the correct unit, so my end result would just have to be by dividing this number by this number. My density comes out 11 grams per cubic centimeter. We look at the variables that we started out with. This is 3 sig figs. This one's 4. We have to go with the least, so I have to add a significant figure here, and that would be my answer for the density. So apparently that sample would be more dense than water, and it would actually sink. We're going to need a little bit more room for the next one because there's a lot more work to do on it. This was question number 12. And it has iron with a density of 7.87 grams per cubic centimeter. And again, I'm just writing down my variables. So I have my density. My mass is what we're trying to find, so I'll put that as a question mark. And the dimensions, or the volume, is 120 yards by 60 yards by 1 millimeter. Since I know I have to end up with cubic centimeters, and these are not in centimeters, I'm going to have to take care of each of these things and convert to centimeters for each one. So the first one I'm going to deal with is this one. Again, we're going to use a conversion chart. We got 120 yards, and then we're going to follow pattern. Well, if I have yards top, my canceling will be yards bottom, or yard, and my next smallest unit is going to be feet. We know that yards is the big one, so we give the big one, and we know that our conversion factor is 3 feet equals 1 yard. Cancel, cancel. Follow pattern, feet at the top, feet at the bottom. Next smallest unit is going to be inches. Which one's the big one? Feet. Smaller one, inches. 12 inches equals 1 foot. Cancel, cancel. Got another step. We got inches, now we can go to centimeters. And we have 1 inch. We'll just change that to an inch. And my conversion factor is 2.54 centimeters. Basically, it's just calculation. And my number here will be 10,972.8 centimeters. That will be my first one. Now, if you kind of look at your number here, this number is half of this number. So I am just going to substitute a 60 so I don't have to put any additional work in. And we will have to only divide by 2 because this is half of 120. So 10,972.8 divided by 2 equals 5,486.4 centimeters. Now we only have this one left, and again we can do our King Henry diet by drinking chocolate milk. And we know this one is located here, and I'm going to centimeters, so we're going here. My centimeters is the big one, and then I put a 0. So I've got 1 millimeter, millimeter, centimeter, big one, centimeter, small one gets the 10, conversion factor, and 1 divided by 10 equals 0.1 centimeter. So now I can multiply these and get my volume. So I'm going to go ahead and erase it because we don't need that anymore and we have our correct units. So then we're just going to multiply these 3 numbers together. And we're going to end up with 6,020,116 and some numbers past the decimal point. And that would be centimeters cubed because I'm multiplying these centimeters by themselves. Those are my acceptable units. Now I can find my mass. Well, if you take a look at the formula, this would be cross multiplying, so I'm going to be multiplying those two numbers, which are these. So all I have to do is just automatically go into calculating it, and we got 47378,320.73. That will be my grams. From those original numbers, I'm going to have to figure out the number of significant figures. And my number of significant figures will actually be 2. So these are my first two numbers. The only two acceptable answers with the significant figure rounding would be this, which you kind of get tired writing zeros, or 4.7 times 10 to the, it's 1, 2, 3, 4, 5, 6, 7, big number, positive exponent, grams.